Okay, so let's take a look at chapter 27, objective 5, gametogenesis in females. So it's broken down into two phases, uh, oogenesis and folliculogenesis. I'm just going to get my little pointer here. There we go. So oogenesis is the production of the gametes, where folliculogenesis is the growth and development of the follicles. This is a very confusing slide, so let's just kind of take it one step at a time here. So we're going to start off in the embryo. So this is the female embryo. Um, the oogonium diploid, it's got twice the number of chromosomes. Prior to birth, mitosis will occur, which means you're going to get double the amount, right? They're genetically identical cells. And this is going to be called the primary oocyte. And because of mitosis, it's also going to have diploid, 2N on the chromosomes. Now, it's going to stay pretty much here. So after mitosis, meiosis 1 is going to occur, but it's just going to kind of stall at that point. Then completion of meiosis 1 and beginning of meiosis 2 will occur once puberty has occurred in the female. And then each month after puberty, that secondary oocyte, which is formed through meiosis 2, is going to just kind of stall again. And then when ovulation occurs, will be released. And that's when the fertilization is going to occur. So the sperm are going to come in, it's going to fertilize the egg. And then meiosis 2 will complete. So after fertilization, meiosis 2 is going to be completed. Now, why does this show 2N where we have a single N over here? So remember, this is haploid, and then the fertilized egg is diploid, because this has now the sperm inside fertilized egg. So you've got the haploid from the sperm, haploid from the egg, which makes a diploid fertilized egg. Now, there are these polar bodies that get formed through meiosis, because remember, with meiosis, you're going to end up with one cell and one active cell in a female and 3 polar bodies is what's going to end up happening. So we got just some polar bodies floating around here. These never are going to become an egg. They're just going to get resorbed back into the female. They're not really going to do anything. Okay, so oogenesis, gametogenesis in females, process begins with that ovarian stem cell. They're formed during fetal development and divide through mitosis. So again, you're getting genetically identical cells. Oogonia form those primary oocytes prior to birth and remain in this stage of meiosis 1 until puberty through menopause. They're just kind of in an arrested state of development. They just kind of stall right there. So an infant is going to have about 1 to 2 million oocytes. By the time they reach puberty, only about 400,000, and then menopause, 0. So once, unlike with the male, sperm are constantly being made, the number of oocytes that a female has are going to be decline over time, because they've all been made prior to actually the female being born. So ovulation is the release of the oocyte from the ovary. This occurs once every 28 days once puberty has begun. And then we have folliculogenesis. This is the oocytes and the supporting cells. So within that follicle, you have the egg and the supporting cells. The primordial follicles, which you don't see in the picture here, they're present in newborn females, and they're in this arrested state of development. They're just kind of stalled until puberty. Primary follicles, after puberty, they're going to be immature, and they're going to grow into follicles, into this growing follicle. So we've got this primary follicle here, which is going to turn into this growing follicle. Secondary follicles, they're going to become larger. They're going to produce the estrogen that we talked about earlier. Again, low levels of estrogen, which are going to prevent the release of luteinizing hormone. And then those tertiary follicles, where only one of these are going to survive to actually reach the stage of ovulation. So you've got several, and it says right here, 20 follicles actually mature each month, but only one of them is actually going to be released from the ovary. So ovarian follicle atresia. This is the process by which immature ovarian follicles degenerate and are reserved resorbed during the follicular phase of the cycle. So I believe someone asked me in class, what happens to the rest? What goes on? So about 20 follicles mature each month due to the presence of follicle stimulating hormones. So they're gonna mature, but only one of those is actually gonna leave the ovary, ovulation. What happens to the other 19? They undergo atresia, which is resorption. They just get resorbed, and are no longer able to turn into something that's going to undergo ovulation. So I hate to say they're wasted, but that's kind of what happens to them. These are the female hormones and how it works with the female system. So we got follicle stimulating hormone and luteinizing hormone, specifically what they're doing for the female, because again, these two hormones are also going to be produced in the male, and they have different functions, obviously, for the male. And then estrogen and progesterone, and exactly where they're coming from. Again, estrogen from the developing follicle, progesterone from that corpus luteum, and it just kind of shows again what they do. So it puts it all on a table form to help understand what's going on with the female cycle. And that's all for objective 5.